What's up guys, welcome to this new video. And in this video again we are back with C++ tutorials of data structures and algorithms. So in this video we are going to talk about prime numbers. Okay, we'll talk about prime numbers, that what are prime numbers and how can we find out whether a number is prime or not using the C++ program. So let's start with it. Okay, what are the prerequisites for this video? First, let me tell you, prerequisites means that what all information you need to know before starting this video. So you need to know about the if else, the loops, especially the for loop and the break statement. Where can you find if else? You can find it in my videos of the conditional statements. Where can I find for the loops? Where can I study about the loops? You can find it in my playlist of C++ data structures and algorithms. The video name is iteration statements. Where can I find information about the break statement? Again, go to my playlist, search for the video switch case and you will find it. Now I'll link all these videos in the description, which are the prerequisites for this video. Okay, so you don't have to go on the YouTube and search for it or anything else. Okay, so now let's start with prime number. Okay, if you already know about the prerequisites, so let's start with it. What are prime numbers? 13, 7, 23, 47, 19, these all are prime numbers. Okay, why are they prime numbers? See, prime number is a number which is divisible by 1 and the number itself. Like I've talked about 13, it's divisible by 1 and 13 only. And any number from 2 to 12, it should not be divisible by that, and 13 is not. That's why it's a prime number. Okay, if I talk about 14, okay, so if I talk about 14, it is divisible by 1 also, it's divisible by 2 also, then 7 also, and 14 also. So yeah, it is divisible by the number itself and 1, but between 2 to 13 it is also divisible by 2 and 7. So it is not a prime number. So in short, what a prime number is, let me tell you once again. A prime number is a number which is divisible by 1 and the number itself. See, every number is divisible by itself and 1. Okay, but I want that the number should be divisible by 1 and itself only, not by any other number. Like if you talk about any random number in the world, 56, it is divisible by 1 and itself. Yeah, but it is also divisible by numbers which are in between. Okay, it is also divisible by 2, it's divisible by 4. So it's not a prime number. Okay. So in this program we are going to see that whether a number is prime or not prime using the C++ program. And how do we do this? Let's start. So I'll declare a variable int n. It's an integer type variable obviously, and we are assigning the name n to it, and I am also declaring a variable check whose initial value I am giving to be 0. Now, why am I doing this? Why am I declaring any variable called as check and initializing it to 0? You'll see it in the program. Okay, you'll see it in the program now. So cnn, first of all the user will enter that number who he has to check for, that whether it is prime or not. User will enter any number, okay, and we'll check that whether it is prime or not. So we first need to input that, and that's what we have done. Now for the loop part, int I equals to I less than n and I plus plus. Why I have written I equals to 2 and I less than n is very important here. Guys, see any number, let's say 5. We know that 5 is a prime number, okay. Now I want that number to be divisible by 1 and 5 only, which means I will check that whether it is divisible by 2 and 3 and 4, that is starting from 2 till n minus 1. That is the condition of my loop, that I am starting from 2 and either I can write I less than equal to n minus 1 or I can simply write I less than n. So that is what I have done. I have written I equals to 2 and I less than n. Remember, if you will write I less than equal to n, then it will be wrong. It will mean that any number in this world is not a prime number. Okay, and that is wrong obviously. So yeah, now I will check that if the n, the number entered by the user divided by I, gives the remainder 0 or not. Now why am I doing this? What is happening? Let's just write the loop part only here, so that you can completely understand what is going on. I'll write the entire loop part and the conditions here only. So yeah, I have written for I equals to I less than n I plus plus if n mod I equals 0. It means that, see, Now let me completely begin with this thing, that why are we doing whatever. Now let's take n, for example 5. Okay, we will check that is 5 modulo division 2 0, is 5 modulo division 3 0, if 5 modulo division 4 0. That is what we need to check, guys. Yeah, because we need to check from 2 to n minus 1 that is it completely divisible by any of them. So how do you check that it is completely divisible by any of the number? By taking the modulo division to be 0. If it is 0, then yeah, the number is completely divisible by any other number, else it's not. So we are doing the same thing here. Now if this n modulo division I comes out to be 0, then obviously the number is not a prime number. Yeah, so remember that variable check, okay, which I initialize to 0, I'll make it 1. Okay, see first here example of 18. So if I talk about 18, it is divisible by 2 only. Now see, since it is divisible by 2 only, I also need to stop this loop at 2 only. Guys, this is important. I have no need to check further. Since it is divisible by 2, it's a prime number. Now no matter whether it is divisible by 3 also, and 6 also, and 9 also, I don't care. Even if it is divisible by any single number between 2 to n minus 1, it is a prime number. So I need to stop the loop as soon as I find that number. Okay, so now that is what am I going to do here. Now let's see what am I going to do here. Let's start with it. Let me first erase all these things which I have written here. Okay, let me erase this also, this line. Yeah, so now let's understand that what are we going to write. We are going to write check equals 0. Remember, check equals 1, sorry. We initialize the check value to be 0. Now if the number is not prime, I am making the check value 1. Okay, obviously I'll display here also that the number is not prime. I can write anything, number is not prime, I'm writing it for short, not prime. Okay, yeah. After that I'll break. You know that what is the break statement? Writing this break will take you simply out of this entire for loop. Okay, writing this break will take you out of the entire for loop. And why do we need to go out of the for loop? I told you that as soon as I find any value of I, let's say I talked about 18, and I told you that the number was divisible by 2 only. So I don't need to go further in the loop, because if I go further in the loop checking every number, it will just increase my time. Okay, I know that the number is not prime even if it is divisible by just 2 only. Okay, so why do I need to traverse the entire loop, travel the entire loop? Okay, I don't need to do that because it's just increasing my time. But I want the program to be efficient. I want to decrease its time. Okay, I don't want to increase it. What I want is to decrease the time. So for any single value of I, if this condition becomes true, then I have to exit the loop. And that is what we can do by writing this break statement here. Okay, that's what we can do by writing this break statement here. And that is why I have written this break statement here. Okay, now we have moved out of the loop. Now if this check equals 0. Now see guys, when the check value was 1, only if the number was not prime. So if the check value at the end of the program is 1, okay, then it means that n modulo division I equal to 0 condition was satisfied. It means that the number was not prime. But we initialize check to 0, and if it is still 0, means that it has not gone into the not prime condition. And if it has not gone into the not prime condition, it means it's prime. Okay, so we'll simply write prime number. Why? Because our program has not moved to the condition of not prime, and since it has not moved to the condition of not prime, means our number is prime. Okay guys, yeah, so this is what we are doing here, right? So let's just summarize this thing. the entire program I have written here. I'll code it also. Let's check this for 19. So is the I will start from 2, okay, and go until 18, okay. Now increment the value of I, okay. So first of all, I'll check that whether 19 mod 2 is 0. It's not 0. I'll increment I plus plus, I'll do it, and I'll check it for 3, still not 0. Again increment the value. I'll go it for 4, that 19 mod 4 equal 0, it's still not 0. Then I'll keep on incrementing this thing until I reach 18, okay. I'll keep on incrementing this thing until I reach the value of 18. Now as soon as I reach 18, answer is still not 0. Now break will take place. Break will take place, okay, and we will not move out of loop, guys. Here cout not prime, I'm sorry guys, sorry. Break will take place and we will move out of the loop, and now we will move on this statement that if check equal to 0. So guys, obviously the check will be 0 because number was not prime, okay. So check is still 0. So we have written that if check is 0, print prime. So prime number will be printed, and 19, guys, is a prime number, okay. So now let's write the code. We are going to write the code for checking that whether the number is prime or not, okay. I hope you understood this code. I am just going to type it out now, okay. In further videos we will also talk about the numbers from 1 to 100, whether they are divisible by basically I'll check that. I'll print the prime numbers between 1 to 100 in further videos, not in the next video. Next video is going to be about Fibonacci series, okay. Next video is going to be about Fibonacci series. This prime numbers printing from 1 to 100, we will do it in further videos, okay. Okay guys, so let's move to the code. I have already saved this file. Wait, let me zoom this for you. Okay, so I have already saved this file using I have used the name prime number.cpp, okay. You can use any other name. So int main. Now yeah, so the program is to identify whether a number is prime or not. So I will have the number, then this variable check, which I told you that I have assigned it initially to 0. So I'll ask the user to enter the number. So enter any number, now I'll check. So for int I equals 2, I less than n, I plus plus. So what are we going to do, guys? We are going to check that if n divided by I gives the remainder 0 or not. So if it gives, then we'll change the value of check and we'll break through the loop, okay. That's what we saw on the digital blackboard, yeah, okay. And outside the loop I'll write if the check still has the value of 0, then we'll write prime number, okay. Here also I'll write not prime number, okay, not a prime number. I'll write it not a prime number. It's important to write that, guys. So yep, this is it. At the end I'll write return 0. And now let's build this program and try to run it. So build and run. So enter any number. If I enter 13, so it's a prime number. Now if I enter 14, so it is not a prime number, guys. So this is it.